In this session, we are going to discuss another data structure queue, and queue is nothing but a sequence list where list of data or set of data will get represented. But here, unlike the stack, here the insertion and deletion will be done from two separate ends of the queue. The queue will have two end marker, one is the front, another one is the rear. Any kind of insertion operation will be carried out at the rear end, and any kind of deletion of data will be carried out from the front end. Queue is a data structure which is known as first in first out or last in last out data structure. So we know that in front of any ticket counter or any kind of service counter, we usually find ourselves in a queue. So the person who has joined that queue earliest will get the service from the counter earliest and will leave the queue at first. So that means first in, first out. So to have a proper idea regarding this particular queue, let us come to this particular diagram. So as I told you that in case of queue data structure, we will be having two variables. One will be front, from where deletion will take place, and another will be the rear, at which end the insertion will take place. Queue can be represented either using an array or using one linked list, where two pointers will be kept at front and rear, and insertion and deletion will take place accordingly. Okay, now let us consider the array implementation of the queue. This is one array which is having 5 locations, and initially the queue is empty, so the array is also empty. When the queue is empty, means the array is empty, then front and rear will be equal to 0, because 0 is not a valid subscript. So that means that front is equal to 0 and rear is equal to 0 indicates queue is empty. Now insert A, then B, then C in that order. So at first A will be inserted at this particular place. So front will become 1 and rear will become 1. Whenever front is equal to rear is equal to 0, that means the queue is empty. Whenever front is equal to rear is not equal to 0, that means only one data is existing in the queue. In this particular case, after insertion of A, the front will be 1 and the rear will be 1, because that is the only one data it is having. But if I insert B, the B will be coming here, so rear will become 2. If I insert C, then C will be coming here, then at the end rear will be 3. Front is equal to 1 and rear is equal to 3. In this way it will work. Now we are going for delete A. Delete A means the first data A will get deleted. So I shall be remaining with B and C. So front will be 2 and rear will be 3, because I have deleted A. Delete operation can only be carried out from the front end. Here the front is equal to 1, so that's why delete operation has carried out from the front end. Now insert D and E. So B and C will survive and D and E will get inserted. So front will still remain with 2 and rear will become 5. Then it is asking to delete B and C. So D will remain and E will remain. So front will become 4 and rear will become 5. Now it is asking for insertion of F. So F will be inserted at the rear end, as insertion can only be done at the rear end. But after D there is no free space. But there are some free spaces beforehand. So insertion can be done in two ways. Either I shall have to shift D and E towards the left, so that I can get a blank space of free space at the end. There I can insert this F. Otherwise I can go for the circular logic. I shall insert F here. I think the first one is involving lateral movement of physical data. So it is time consuming and it is having a very costly affairs. So it is better not to shift my data, but it is better to go for the circular queue, because in that case there is no need to have any lateral movement of physical data, but I can utilize my insertion operation and in a circular way. So D and E will survive here and F will get inserted at the front, at this particular front of the queue, front of this array, but it is actually the rear end, because the rear end can, at the rear end we can perform the insertion operation only. So what about D? D is at the 4th place and rear is at the 1 place. So whenever front is greater than rear, that indicates that it is in the circular logic, it is in the circular way. When front is greater than rear, it indicates that the circular logic is there in the queue. Now it is asking for insertion of G and H. So front D, then E, then rear end is F. So G and H will be inserted at the rear end. So they will be coming here. G and H will be coming here. So front will still remain with 4 and rear is equal to 3. So when front is greater than rear, that means the queue is having data in the circular logic. Now delete D and E. So D and E will get deleted. So I shall remain with F, G and H. So here my rear end will remain as 3 because we are doing the deletion. Deletion will be done at the front. So now front has become 1. So here the front is not greater than rear, that means I am in the linear logic. Insert I, so F, G and H will survive, I will be coming at the last. So rear will get changed, front will still remain with 1. Now delete F, that means I shall be remaining with GHI, and here front will be 2 and rear will be 4. In this way, I have given you the idea how this insert and delete operations are getting carried out on a circular queue implemented through an array, and how the front and rear addresses are getting updated. On a queue, we have basically usually get 2 operations. One is the insert and another one is the delete. In the next videos, we are going to discuss the algorithm for insert operation and the delete operation. And those videos will be in the continuation of this current video. Please watch all of them and you will be solving some problems on queue and stacks and other topics also. And thanks for watching this video.